All right, so today we're moving on to the next thing. Again, this is not going to be on your first exam next week. You're free to use functions and methods on your exams and all of your assignments if you want to going forward, but we're not expecting it on this week's hack or next week's exam at all. You already have, remember that we are online, so if you have any questions, you can post to Piazza or to the YouTube live stream here. You've already have plenty of familiarity with functions because you've been using them implicitly up to this point. Everybody here has written a main, right? Main is a function. Everybody here has used the math library. The math library has functions, square root, sine, etc., right? So what is a function? Well, a function is a reusable unit of code that takes inputs and may produce an output. And what I'm going to do is I'm going to really highlight that key word there. It is a unit of code, right? That is going, when we get into unit testing, that will be our unit that we're actually going to be testing, the indivisible thing. The way that you should look at a function is this magic black box, right? It's a black box, like an airplane black box, because all the inner workings happen inside, and you're not allowed to look inside and see how it works, right? You're not allowed to see how the sausage is made or whatever. Instead, you just give it inputs, it gives you outputs magically, right? Now, when you, that's how you should look at it when you actually test it. Now, if you ever actually have to write it, then you have to rip that box open and you know, actually implement the function and make the sausage or whatever. But otherwise, you should view them as reusable units of code. Anytime you find yourself writing a piece of code and then you use that in 2 different places, 3 different places, 4 different places, that should be screaming out to you. Put this into a function and reuse that function, right? Again, you are already familiar with the basic functions in both languages. You're familiar with functions from math, right? So if I gave you this math function here, f of x is equal to x squared. What's the name of that function? It's not a trick question. There's only a couple of symbols up there, right? Which one is it? F, right? Well, why is it f? It's just a function, f for function, right? It's not, they're not creative, right? Just like when a mathematician uses x, y, z, a, b, c, what do they represent? I don't know. It's abstract, right? Who cares? When you actually apply the mathematics to a problem, then you're graphing time with respect to money or something like that. Then they have labels, right? Same thing with functions. The name is just simply f. We'll, of course, be able to use better named functions that actually have, you know, a meaning to us. What's the input to this function? X, right? What's the output of the function? Y, we usually call it y, which is f of x, right? The left-hand side, right? So it takes input. In this case, it takes one piece of input. It produces output, the function's value, y, right? You can also have multivariate functions in mathematics, right? You can have f of x, y, f of x, y, z. You can generalize that to an entire vector, f of x1, x2, x3, x4, dot, 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 x100, right? That's a 100 variate function. If you get beyond 2, though, you can graph this, the 2 variate function, in 3 space, but once you go up to 3 variables here, and now you're in 4-dimensional space and you can't graph it anymore, and at least not in a way that humans can visualize it. Right? You can also have a function with no inputs. A function with no inputs is called a constant, right? 3 is a function with no inputs. It's always 3. It's a horizontal line. Why do we have functions? Functions facilitate code reuse, right? You don't have to copy pasta chunks of code. When we did our loan amortization table, we had need of rounding to the nearest cent. We did that in at least 2 places. That is enough to justify, hey, maybe we should have a round to cents function, right? So that we don't have to copy, paste code, copy, paste code, copy, paste code. Instead, you put them into a function and you call or invoke that function. So those are the key words there, your vocabulary words for the day of what it means when you use a function. You call it or you invoke it. right? And so therefore we have this calling function. The function A calls function B. That's the calling function and the called function, right? Or the callee and the caller, or caller, callee, whatever, right? Lots of different ways of putting it. It also goes into back to the DRY principle. Don't repeat yourself, right? Don't repeat that chunk of code over and over and over again. Put it into a function and be done with it. And then it also supports procedural abstraction. So let me ask you, how does sine work? Or pull out your scientific calculator. Did you ever wonder what it does when that button, when you hit that sine button? Right? Maybe you wondered about it, but did you let it interfere with your daily lives? Right? No, you moved on, right? Who cares? Who cares, right? It just works, right? It could be, and if you're really interested, it could be a Taylor series. Now that you're in calc, you know how to calculate sine using a Taylor series, right? It could be an interpolation method. It could be any number of things. Back in the day, before modern computers, they had these big giant lookup tables, right? Where they published entire books of, I need to compute sine, sine of 3.8472, right? And then they would jump to the sine page, and then they'd look at a row, they'd look at a column for the approximate value. There it is, right? That's what they did, right? Those are called lookup tables. In fact, computers still use them. Even modern computers still use them. We don't care, though. We just want to use the functionality without having to worry about the details, right? Right? I just want to call the sine function because I'm not solving the sine problem, whatever the heck that is, right? I am solving some problem that uses sine in order to solve another problem. And I want to solve that problem. I don't want to have to solve the sine problem. I don't want to have to resolve that problem every single time I encounter it. So I put it into a function and I'm done, right? By encapsulating functionality into a function, we don't have to think about the details, right? Other advantages here are that standard libraries and external libraries come with a lot of testing, debugging, optimization, etc., right? That you cannot hope to replicate. So, stand on the shoulders of giants, right? People, thousands of person hours have been put into developing these things, optimizing these things, and making sure that they work, right? Don't let their work go to waste, right? Use the functions when they're there, right? Generally, you don't want to roll your own. We use that term, right? Functionality, unless you have to, right? In other words, you don't reinvent the wheel. Instead, you ask yourself, when faced with a problem, what is the first question you ask? So when you're faced with a problem, what do? I need to round a sense. What's the first question you should ask yourself? Has somebody else already solved it, right? Don't reinvent the wheel, right? Is there a round a sense function already? And if the answer is yes, good, you're done. You don't have to solve it. It's already been solved, right? If you are designing a mechanical device and mechanical engineering is putting together some sort of a device and part of it requires a motor, do they reinvent the motor? Do they design their own motor? No, they take off-the-shelf components and put them together for a prototype, right? If they don't have a motor specifically designed for those needs, then they have to go and develop it. Or maybe they can take an off-the-shelf motor, modify it with some gears or something to get the exact RPMs that they want or that they need, right? And that's what we'll do with our functions. No, we don't have a round descent function, but we have this round function that we can take off the shelf, modify it by multiplying by 100, dividing by 100, and solving that problem, right? So, has it already been solved? Always look for off-the-shelf solutions. Those are all of the justifications for why we want functions. Now let's talk about how we actually do it in, say, C. Right? Functions in C to begin with. So just like variables, if you're going to create a function, you need to declare them first. And a declaration in C means defining a prototype. Declaring in C means writing a prototype. Now this is not a prototype as in the mechanical engineer who's creating a prototype of his robot or something like that. Instead, it's a prototype as in a signature. A prototype in C is a signature. A signature is a uniquely identifying thing. It consists of the function's name, the function's input and types, right? And the function's output type. Right? Function. There we go. Misspelled them. So to understand this, what I'm going to do is I'm going to come over here to one of the last things that we did here. This is computing the arithmetic geometric mean, right? But this is in Java. So what I'm going to do is I'm going to steal this code and eventually take it over here and put it into C. Well, let's go ahead and do it this way first, and then let's make sure, get some more practice translating between the two languages. CSCE 155H. Is that going to work? GCC, with all the warnings turned on, demo.c. Nope. So what's the only thing that we have to change here? What's the math library in C? It's up there. We don't have math dot. And I'll ask you, is abs correct? Nope. It's a floating point number, doubles. So what should I have? Fabs. There we go. And then I guess I didn't print it out. How could I print it out? By simply getting rid of system.out. All right, let's make sure that this still works. Does anybody remember what the AGM of 42 and 101 was? Anybody have great memory like that? Oh, and there's more math there. There we go. And what else do I need to give it in order to compile for math and C? At least on this, LM. There we go. Is that correct? I assume it's correct. Go ahead and look it up for me, please. But otherwise, hey, this seems like a pretty nifty piece of functionality here. Right? I've got like a block of code here that computes the AGM. Let's start by creating a function to do this for us so that I can just call this AGM function. It is not part of the standard math library. The math library does not have an arithmetic geometric mean function. So if we don't have it, there's no off-the-shelf solution. We build it. For now, I'm going to put the prototype above the main because if you're going to use the function, you have to declare it before you use it. Right? So I'm going to go all the way to the top here in the main. Is this big enough for everyone? Bigger? Good? Okay. All right, and I'm going to define the prototype. Remember that the prototype is the function's name, the function's inputs and types, and the function's output type. So what would be a good name for the arithmetic geometric mean function? AGM? Okay, I like that because that's what it is. I mean, if you go to a standard calculator, it'll say AGM. If you wanted to be more verbose, arithmetic geometric mean, right? Or you could even go compute arithmetic geometric mean, right? In general, your variables are going to be nouns because they're things. In general, your functions, they do things. They are verbs, so you should name them after what they do, right? Compute this, get that, do this, right? Execute that, initialize that, whatever, right? In this case, though, we have an argument that, well, let's just keep it simple, AGM. Why do I have parentheses there? It's because of parameters. And why do we have parentheses? Why do we use parentheses in code? Because of those math people, right? And we just stole it from math, right? You'll find that that's the same for most stuff in programming, right? Why reinvent the wheel when we've got something that we can, already use? So parentheses. That's the name of the function. what's the function's input and types? What do we need to give this function in order to compute the arithmetic geometric mean? Well, how did we do it up here? 2 doubles. So double x and double y. Do those x's and y's represent anything in this particular case? No. If they represented something like, say, principal, if you were doing this with a loan, monthly loan payment or something, principal, rate, terms, right? Those would be appropriate variable names. Here, they're just numbers, so whatever. Right? The function's output type. So what is it going to return? A double. There we go. And because it's a declaration, at the end of the prototype goes a semicolon in C. In addition, when you create a function, you should always document it. When you create a function, always document it with doc-style comments. Right? We're not going to require you that you use doc-style comments, but you need to comment. You need to document every function, and frankly, you should just get in the habit of doing it. Right? Doc-style comments, as in something like this. Right? Because unless you were familiar with the term AGM and you knew what an before we did the exercise, had anybody ever heard of the arithmetic geometric mean before? Probably not, right? It's kind of niche, right? That's why it's not in the math library. So we need to document this. What does this function do? Computes the arithmetic geometric mean of the 2 given values, x and y. Okay, great, that's it. What if I want to know more for, oops, yeah, go away. For more information, see, here's another cool thing. If I want to refer to back to what was the arithmetic geometric mean before, Wikipedia arithmetic geometric mean. I'll just go ahead and link to the Wikipedia page on this. There we go. See, and I'll put it into HTML. If you don't know HTML, that's fine. See this article. But that's why we use doc-style comments, so that we can embed HTML, we can embed other things inside the comments, and I'll show you what it looks like in Eclipse here when we do the Java version. Okay. Otherwise, do you see any code attached to this thing? Nope. So what we have to now do is later on, you provide a function definition. You repeat the signature, but no semicolon. Instead, you provide a function body using opening and closing curly brackets, ... Right? And by putting opening closing curly brackets, you are basically saying everything inside this function, all this code inside the function, that's what gets executed when somebody invokes or calls that function. So let's do that over here. I'm going to take this function down over here, put it over here. No semicolon, instead function body. Now, should I put documentation here too? Probably not. Let's go back to what that dry principle, DRY. Don't repeat yourself. If you've got documentation in one place, that's the only place that it should be. Because if you have documentation in 2 places, 3 places, 4 places, right? And you go and change that documentation, now you've got to change it everywhere. So generally, you only put documentation with the prototype in C. What's in this function right now? Nothing. What if I were to compile this? It's going to warn. Control reaches end of a non-void function. Remember that we're returning a double value here, right? And do we in fact return any value here? Nope. You're familiar with the return value here because of main, right? Main returns 0 because it's done and it exits with no error. Well, what should AGM return? AGM should take all of this, right, and return the final value instead of printing it. In fact, I'll go ahead and cut and paste all of this stuff and move it down here. What do we keep? What do we get rid of? Are our inputs always going to be 42 and 101? No. Epsilon? Maybe we can make that into a variable, or maybe we can make that into a global constant. I'm going to leave it like this for now. Right? Otherwise, we take the current A and the current G and copy in X and Y. We go through our while loop here until they converge. And instead of printing them, what are we going to, printing the result, what are we going to output? Output current A. Nope, we are going to return current A. Right? So you gave me these two inputs. I'm a black box now. I go off and do all my work over here without you seeing how I'm doing it. I finally produce a result and I give it back to you. I return it. This is just like square root. Square root, you give me one input. I do my magic square root stuff over here and I give you the value back. Right? Let's go ahead and use that now. Instead of current A, what I'll say is double result is equal to, now I need to invoke this function. I need to actually call this function, just like square root, X and Y. There we go. And I don't have a current anymore here. It's the result. Right? Let's go ahead and see if it still gives us that answer. I think it was like 68 something. Yep, still the same answer. But the code has been encapsulated into this function over here that we could reuse over and over and over again. Right? Handy. I will draw your attention to two facts here. How many X's and Y's do we have? There's an X and a Y, 42 and 101. Are there any other X's and Y's? There's that X, there's that Y. Are those the same thing? I'm not sure. What if I called these A and B, and these A and B? Now, are they the same thing? Is A and B and X and Y the same thing? Is this A and B right here, and the X and Y that's in this function, are they the same thing? Think about that, right? So we'll come back to that later on. Right? Existential, does it exist? Right? For example, for int I equals 0, I is less than n I plus plus. Right? Do something. For int I is equal to 0, I is less than n I plus plus. Do something else. Is this the same I as this over here? Nope. So let that inform your thought process on thinking about A, B, and X and Y here. Right? Okay, so later on you provide the actual definition, sorry. All right. Convention in both languages is going to be use lower camel casing for function names. Right? Let's see. The code, we already talked about invoking whatever. Use the return keyword to return a value from the function to the calling function. There we go. After or when the function returns a value, control is returned back to the calling function, right? Any variables inside the function are local to the function. This goes to scoping. Now, to draw your attention, that's what I was kind of hinting at with X and Y and A and B. But let's come back over here and look at another explicit example. Epsilon. Where does epsilon exist? It's declared on line 31. So it lives in line 31, line 30 all the way to 38, right? Does it live after this function has returned? Nope. It's locally scoped. If I tried to print it out here, say printf epsilon is %f and the line, epsilon, there we go. Is this going to compile? Nope, because it doesn't know what the heck epsilon is. Epsilon is a variable that exists inside this function and only inside this function. It was born on line 32 and it dies on line 42 after the function returns. It is gone. So nope, it is locally scoped to the function. Parameters likewise are locally scoped. We'll understand that when we look at functions at a deeper level. So what about functions in Java? Right? Sorry. Why did I put that into quotes there? There is a small technical difference that you don't need to really worry about, and I won't worry about. But technically, in Java, functions are methods. So Java methods. The reason being is that when a function exists by itself, like in C, we've got square root, right? That's a function. But in Java, we don't have functions because everything is a class or belongs to a class. So the square root function, that's actually inside the math class because we do math.square root. And because it's inside the math class, it is a method of the math class. We don't say functions. That's the technical difference. I will use them interchangeably, and I don't care if you use them interchangeably either. It's just a technical detail that only pedantic people really care about. Right? And again, it's because everything in Java is a class or belongs to a class. For now, we're going to make all of our methods in Java, functions in Java, static methods. Don't worry about what that means just yet because we'll get to object-oriented programming slightly a little bit later. But that just means that they belong to the class. So when you use them, math.square root belongs to the math class. When you invoke it, you need to use the class name that it lives in and then .square root. Okay? So let's go ahead and come over here and show you the exact same process. I'm going to go ahead and copy this though. Let me go ahead and copy. Verify. We'll call this, I don't know, AGM or my math. There we go. And get rid of this. My math. There. Now I'm in my math class instead of the demo class. I'm going to create a function that basically does this stuff right here. We do the same exact kind of syntax, but we have public, static in front of it. Public simply means that any other piece of code outside the class can see it and use it. If you had alternatives would, of course, be private. Right? Nobody else can see it or use it. And protected, that doesn't really come into play until you get to inheritance, so don't worry about that. Public and private. What if we made this private? Private static AGM. However we're going AGM. However we're going to do it. Nobody could use this function except for this class. Right? It kind of limits its functionality. Imagine if all the math class stuff were private. Right? Let's go over to math here, and let's look at find absolute value. Oh, well, okay, arc cosine here. Imagine if it were private instead, and I'm not able to edit this because it's read-only. But what if I made this private? Nobody can use the arc cosine function anymore. Right? Okay, kind of useless then. Why did you create it? We're going to go ahead and create a public static, and then my return type here is going to be double, just like over here in C. Right? In fact, I could almost copy this entire thing here. Right? The only difference is that I've got private and static in front of it. Otherwise, everything else is the same. And the other difference is that we do not have prototypes in Java. Right? We just create the function, and that's it. Or create the method and it exists. We don't need to declare it up here and then later on somewhere else provide a definition. The prototype and the definition are one and the same. Likewise, we take our doc style comments over here and we do the exact same thing here. Okay? Now it's complaining because I have not actually returned anything. So let me just go ahead and return 0 for now, just to get that off my back, so that I can go ahead and show you what it means when, oops, is never used, because I made it private, public. There we go. That warning goes away, good. There's the power of doc-style comments in a proper IDE. Right? Computes the arithmetic geometric mean of two given values, x and y. For more information, see this article. You can even click on it. There's the arithmetic geometric mean article in your IDE. It nicely, formats everything for you is what I wanted to say. In fact, if you did this from the start, you'd also get this formatting. The parameter x, the first value, this is kind of stupid documentation, but I'm doing it to show you. The second value, right, returns the arithmetic geometric mean of x and y. Right? There we go. And see, it's all nicely formatted right here. Right? In fact, you can even embed more HTML here. Right? X and Y are values in the code. You can surround them with code and code. How did that change the rendering over here? Squint really hard. It's in monotype font now. Right? And it's so now you know that it's referring to this thing over here. Right? You can do stuff like this. This is not in the standard link math. Not my math, but I want an external link here at java.util.math or java.lang.math. Yep. Library. Will that work? Nope. Okay. I forget how to render it, but you can link to other parts of your code as well, right? If I wanted to link to another class or something like that, I could use a special markup language that did that, right? All right, let's steal our code down here. There we go. And put it in here. There. Format it up. Not fabs, but math dot. And not square root, but math dot. There we go. Now I can get rid of all this stuff, and I can simply use that function. How do I use that function? Well, if it were the square root function, I would use math dot. This is not the square root function. It's in a different location. It's my math dot AGM of x and y. Right? That returns a value, and you can then print that value. There. Done. Now you might ask yourself, do you need to put the function up above the main before you use it? The answer is no. You can put them in any order that you want. It's called hoisting. The compiler goes through and says, all right, here are all the functions. I'm going to compile them all, hoist them all up to the top so that I know about these functions. But it is best practice, style-wise, to put them in some sort of order. Generally, the main method, if you have a main method, belongs at the bottom. But you don't need one. Right? Is this an executable class anymore without a main? No. Main method not found in this class. It's now a library, right? I'm not actually going to execute this. Instead, I'm going to go to my demo and use it, right? Double result is equal to my math in a completely different class. Remember, this class is called demo. In my math class, I'm going to have AGM of x and y. There's the result. So now if I've got a whole bunch of mathy stuff or utilities or error distance stuff, I can start putting these into like my own libraries, right? Separate the code so that everything that's responsible for math stuff is over here. Everything that's responsible for financial stuff is over here. Everything that's responsible for something else is over here. It allows me a way to start organizing code at a much larger level. Not just functions, but collections of functions which formulate libraries. Okay? There. Get rid of that. Questions so far on this? And by the way, this is runnable now, and it runs just fine. Okay. So for now, we'll restrict our attention to public static methods. Right? To invoke a method, you use the class name plus the dot plus the name of the function. Okay? So for example, two examples that we've seen so far, math.squareroot or mymath.agm, like we just did. Right? Yeah, I'm going to skip that for now. Yeah, go ahead.
So is it best practice to have all of your functions in one library?
No, that's the God class,
Okay.
right? If you put everything into one class, that class knows everything, it sees everything, it does everything, right? That class is God. You don't want to do that. You want to separate things out. Now, if you've got 5 functions that are very, very closely related, right? Distance functions, right? Euclidean distance, air distance, driving distance, right? These 3 functions that compute distances. Put that into the distance utils library, right? But does compute the monthly payment of a loan belong in that library? Probably not. It does something completely, that one of these things is not like the other, right? Put it somewhere else. So the organization is, at that point, then you can argue about, well, this thing is closely related to this over here, and it's closely related to this over here. Do I put, where do I put it, right? Then you start, whiteboarding stuff, and you start getting other opinions and debate about it. Right? All right. A method or function in both languages that doesn't return anything is called a void function. Right? And you can have those. Right? Let me go over to my math function over here. Public static void do something. Right? Printf or system.out.println. I'm doing something. There we go. What is the return value here with the return type? Void, nothing, right? Does it return anything? If we tried to, that would be a compiler error. Return 0, no. You said that you don't return anything, don't return anything. Well, how do I return nothing? Return nothing, right? Now, it works perfectly fine if I didn't have that explicit return statement. One will be provided for you, right? But it's best practice to include it. What does that look like in C? And take it over here and translate it. We don't have public static. We just have void do something. There's my prototype. To do document. And then down here, what does it look like? Again, no public static, no system.out, just printf. Virtually a one-to-one translation minus these 2 or 3 differences between the 2 languages. Right? Okay. You can make the return type void to indicate that explicitly that it returns nothing. Even if you don't need to, you should still have an empty return statement. That is, statement. Return nothing. You can have a function that has no input. And that's actually the same example that I just used. What's the input to do something? Nothing. You could, if you really wanted to be explicit about it, put void in here. Don't do that though. It's weird. It's different. Nobody does that. Right? I think you can do the same thing over here in Java, but I'm not too sure. Nope, it doesn't even allow you to do that. It's too weird. It's too different. Java says no. Right? You can do that in C, but you should not. Right? Just leave it blank. Right? If it's no input, then the parameters, the inputs, will not exist. Right? Another issue is called function overloading. Right? In C, to compute the absolute value, you can use abs, but also that's for integers, right? What's the absolute value function for floating point numbers? Fabs. Did you also know that there's another labs, which is for longs, and lalabs, which is for longs, and there's a bunch of others. There are at least a half a dozen of these things, etc. All right. each function operates on a different type, right? Absolute value. There we go. Int, double, etc. Right? In C, you have to use different function names because C does not support function overloading. Being able to define multiple functions with the same name. That's why we have to have abs, fabs, labs, lolabs. Function overloading, if it's built into a language, means that you can create multiple functions with the same name. We have that over here in Java. Do I have to use abs and fabs and labs? Nope. I just use abs. Why? Let's take a look at the actual library over here. Right? For doubles, there it is. And then it does this thing right here. Where's the other ones? For floats, we have another one with the exact same name. It just takes a different type. For, well, not that one. For longs, we have another absolute value function. We also have, I think, int. Right? Yeah, we have at least 4 here that I count right off the bat. Right? So how does that work in Java? When I'm calling this absolute value function, how does it know which one of those things to call because they have the same name? Right? If I have Joe, and Joe, and I say, Joe, do this thing, how do they know which one should be doing that thing? Right? I have 4 people named Joe. I have 4 people named Abs. Right? How does it know? Well, what am I passing to this function here? Current A is a double. Current G is a double, so their difference must be a double. And so how did it know to go to the one that took a double? The compiler saw what values I was passing it. And it deduced, this is called a static dispatch. It said, okay, you meant that Joe over there. I will dispatch that information to that Joe when I compile this program. That's the Joe that should be called. Right? That's the absolute value function that should be called. And the compiler takes care of it. Right? So in Java does support function overloading. Again, method overloading. It uses static dispatch at compile time to deduce which method actually gets called. Right? So not magic, but it's all opaque to us. We don't have to worry about it. Right? The compiler takes care of it. In general, because of this, you should be very careful in C about polluting the namespace. Right? Imagine I want to create a function called init, short for initialization, I-N-I-T. Right? Let's do that. Instead of doing something, let's do something a little bit more concrete. Init. There we go. So this is the program initialization function. I'll go back and initialization function. There we go. Right? And I'll change it to do something right here. I'm doing initialization stuff. Right? It's just initializing the program or whatever, right? Whatever it needs to do. It needs to make a connection to a database. It needs to open up a socket for network communication or whatever. Whatever needs to be done with initialization. By making that choice of function name, what have I done? Can anybody else use the init function or define their own init function? Nope. Once you have one function with one name, that's it. The game is done. The namespace, that's what it's called. The space of all the names of all the functions that you can use. If I tried to call this SQRT, do you think that this would work? Nope. Why? Because the math library has already defined it. Right? So be very judicious in which functions you are creating. Because if I, for example, wanted to bring, I'm writing a larger program and I need to bring in library A and library B. Suppose library A defined their own initialization function, init, void init. Library B did the same thing. We now have a conflict. It's not going to be easy to use both libraries at the same time because one of them has already polluted the namespace with this name of init. Right? Now the trick to that is usually libraries will prepend all of their, in C, libraries will prepend all of their special functions with some sort of library name. For example, library A init, right? And then we can go ahead and go over to library B that has prepended it with library B init, right? And now they can live happily together because they're completely different names. But once you've created a function with one name, that's it. You've polluted the namespace. Nobody else can use that function name, right? Without doing some really backflipping kind of tricks, right? Do we have that issue over here in Java? What if the math library did have an AGM over here, but I wanted to do my own AGM because their AGM was, I don't know, stood for something else completely different. Arithmetic, Gaussian multiplication. I just made that up. It's not real, right? Suppose that somebody had already made their AGM that meant something completely different. That's okay, because their AGM lives over in their math library. My AGM lives over here in my math library. And in fact, you can even have two classes, both named my math, in different packages. Right? That's why we generally encourage you to use unl.csc. Should be SOC now, right? We're now the School of Computing instead of Computer Science and Engineering, right? So I still need to go back and start changing all that. Don't worry about it, right? Don't change it for this year. Why? Because, well, if you've got your my math from, I don't know, who's the top prospect for coaching right now? The guy from Iowa State? All right, nobody follows that side. It would be like what? Iowa State University, ISU, dot, and then I don't know what their computer science department is or whatever, right? ISU and then .CSE. We'd keep things separate and organized and distinct so that we're not stepping on each other's toes. Let me undo that, right? There we go. All right. So don't be careful of polluting the namespace because of these things. When we come back on Friday, by the way, I will be announcing the format of the exam later today after I've gotten all the labs done and answer that one question on Piazza about rounding. But when we come back on Friday, we'll talk about modularity in both languages. I already just gave you a preview of modularity in Java. Put things into different packages, put things into different classes inside those packages, put things into different methods inside those classes, inside those packages, right? That's your organization. Modularity in C is a little bit different because what we do is we take the prototypes and the definitions, we separate them out into multiple files, and then now we need to do some extra steps in order to compile them all together. Okay? All right. See you on Friday.